So now that you've seen what an insoluble salt does in water, basically dissolves just a tiny bit, but it's enough that it makes a difference in a lot of our industrial processes and in our body and in other things. So it does matter, but it's just a teeny tiny bit. I've got a little bit of terminology for you to be aware of. And so if you look on the left-hand side, notice that, like before, we have a KSP chart. I wanted to point out that this is organized by the name of the element. So like aluminum alphabetically, and then barium, then bismuth. You can use Control F and jump to it if you aren't sure, but on the homework, you're going to want to use this to get you to KSP. On actual tests, like quizzes also, but for tests, you're going to be given a KSP value because the KSP, obviously by that point, assuming you can use a chart and get a number off a chart. Note that, like everything else, the KSP, like all the other Ks, it's at 25 Celsius. So if we ask you to solve for KSP for aluminum hydroxide, and we're like at an undefined temperature, well, then don't jump over here and just grab that number and try to stick it in as your answer, because at another temperature, we can give you any type of numbers to figure out the solubility of it. So that's where the KSP chart goes to. It's linked at the top of the lesson, so you should be good on saving that KSP chart and getting back and forth to it. Make sure you use the OpenStax one because that's what's tied to the homework numbers. So there's two terms you need to know about. One of them is actually where the SP and KSP comes from. So S, solubility, P, product. So it's kind of funny because we'll be like, hey, find the Ka of an acid, find the Kb of a base. But for whatever reason, we actually use the technical terminology when we're talking about the KSP. So instead of saying, hey, find the KSP, which I love to say, find the KSP. Instead, we say, hey, find the solubility product. You're loving that, right? I love that too. So solubility product, what it is it's just a hidden way of saying, hey, solve for the KSP. And you solve for this KSP in the same way that you solve for all the other KSPs. So you're going to see that coming up and how to solve for it. But that's the word there, solubility product. And the word product is because you are literally multiplying the two parts of an ion. Like I'm going to jump to BaCO3. When you're writing this as a solid, it doesn't go into the KSP expression. But when you're writing it as ions that are aqueous, it does, because they're AQ. So products over reactants, but the reactant is a solid, so we don't put it in. So I'm just putting my reactants in, and so you can see you are literally multiplying, being, it's a product, it's multiplying, but these are also the products. So it's how soluble are those products. So if that helps you remember what it is, that's great. Otherwise, we're not going to ask you to solve for KSP, we're going to ask you to solve for solubility product. Same types of processes as solving for Ka, Kb, K, everything else. The other word right here is molar solubility. This is our hidden way of saying, hey, just solve for X. Like before we had like a hidden way in the acid section. We would say, okay, solve for H3O plus, which was X. So you would know to solve for X. Now we've changed it again, and we're calling this molar solubility. Note molar, molarity, X is in molarity, which makes sense because that's also how we've solved all the other Ks. And then solubility, it's how soluble X is. And so molar solubility basically just means solve for X.